means just visited the questions which were available to you. So there are several questions which we can discuss here, because there are a lot of questions I have given you to solve. So for example, like just keep answering me, okay? Like in question, it is given that H2 is gas is converting into H2 gas is converting into this 2H of gas. Okay, so both are gas present in both side of the equation. There are gas molecules. Okay, so can anybody comment that entropy has increased or decreased? I want I want answers from everybody. Alina, have you gone through this chapter earlier?
No, sir.
You were in last class, right? Means the
Yes.
just earlier class. Okay.
Yes, sir.
Okay. So are you here for the equilibrium chapter?
Yes, sir.
Means after this chapter, in some time we will go through. We will go to equilibrium chapter. Okay.
Okay, sir.
Because in NCERT after this chapter, equilibrium chapter is given, and so Ali, Jovita, Jesslyn, Sabiha, Shaima, and Zainab, what do you think? Entropy has increased in this or decreased in this question?
Increased.
Increased. I want to know the answer from everybody. If you cannot, if you are having issue with your mic, you can answer in chat also. No problem in that. I just want to have response from you. Okay. Okay. So, good. So I got a lot of answers from you. So where were we? Thus entropy has been increased. Why? Because we are having one molecule here only, and we are having two entities. Yeah, two atoms here. So two entities. Sorry for the grammar part. So what we are having, one molecule. So what we are having, it has been increased. So randomness has increased. So entropy has been increased, right? Everybody.
Yes.
Let's see with another example. NaHSO3. It is a solid which is converting into Na2CO3 and CO2 and H2. Okay, this is in gaseous form. This is in gaseous form. This is in solid form. Can anybody comment? Anybody? Zainab, you tell me. Entropy has been increased or decreased in this reaction? Zainab, you can send message in chat also. See, I'm not asking you all to turn on your cameras. Why? Because if you are giving some responses, then it is well and good for me. Nobody's interested with, means I want answers from you only. Zainab, Zainab is having some technical issue. Shaima, what do you think? So Zainab has answered. Okay. Shaima,
Yes, sir.
entropies are increased or decreased?
Increased.
Okay. Why so? Hmm? Means what do you think? जो भी था,
Yes, sir.
why the entropy has increased? Or it has been decreased?
Increased.
Hmm? The question is why. I have got one response. Why? Okay. So the student which has responded me is talking about temperature. So here there is no temperature thing here. So actually what is happening, the solid thing is converting into solid. One product is solid, one product is gaseous, and another product is also gaseous. So entropy should be increasing or decreasing? Entropy should be increasing or decreasing? Entropy is, randomness. So randomness has been increased or decreased if anything is converted into solid into gaseous form.
Increased.
Hmm? Ali?
Increased, sir.
Hmm?
Increased.
Increase, simple. The particles of gaseous, gaseous are more free to move than solid. So when they move, the entropy will increase as randomness has been increased. Now, Jovita, comment on this. The solid crystals are converting into liquid. Then what will happen? It will increase or decrease?
Increase.
Increase, simple. Solid is converting into liquid, so it will obviously it will increase, right?
Yes.
Understood?
Yes, sir.
Another good example which was in homework is solid at 0 Kelvin. The process is solid at 115 Kelvin. Okay. So, Jessalyn, kindly comment on this that what should be the answers. Entropy has been increased or decreased? No problem. Just comment. I will explain because huh?
It increased.
See, we haven't talked this about it yet. Actually, at 0 degree Kelvin, no, I have talked about it. At 0 degree Kelvin. I've already told you that we experimentally and theoretically also we don't go below 0 degree, right? 0 degree Kelvin. In Kelvin, or we can say minus 273 degrees Celsius, we don't go below this temperature. Okay, below this temperature, we assume it that there is zero vibration. There is zero vibration. Okay, so at 0 degree, 0 Kelvin, we have zero vibration. Okay, So as we increase the temperature, vibration will increase, right?
Yes, sir.
Vibration of particle will increase. So what do you think, Jaslyn? Entropy will increase or decrease?
Entropy increases.
Increases, right? As the vibration starts, the entropy will increase, right? Everybody. Sabia, you got the answer? Understood the problem? Sabia, you can message also. No issue. What do you think? Okay. So can you show the question? Question is not visible. Question is that we have to, compare. We have to comment on that: is entropy increasing or decreasing? These are the 4 questions. Entropy. We have to comment on entropy. Is entropy increasing or decreasing? So here it is increasing. In this also increasing. This also increasing. In all cases it is increasing. So if you want to write the question, entropy increasing or decreasing? Got it? Everyone?
Yes, sir.
Yes, sir.
There are more examples, means there are several examples which we can do it. Like for example, I've already told from graphite to diamond if it is converting. Do you remember, everyone? Graphite to diamond, what will happen? Entropy will increase or decrease? Ali, what do you think? It should be already in your notes. Entropy will increase or decrease? I've
Decrease.
already decrease, right? I've already told that this. Okay, good answer, good, Ali. So graphite has, slippery structure. The structure, I've already shown you the structure of it. So the molecules slip over it. So they have some movement. So there are some movement. In diamond, there is no movement at all. So entropy will decrease, right? Everyone? Hello.
Yes, sir.
Yes, sir.
Okay. Now there are some numericals also, like calculate the enthalpy of vaporization. Let me show it to you. Like this was a question in your homework thing. So you have to, what you have to find? Enthalpy of vaporization, right? So in this thing, what you have to do? Entropy is given. Okay. Entropy is given. Enthalpy of vaporization it is asking, and the temperature of this boiling point of ethanol is given. So obviously at boiling point only we can find the enthalpy of vaporization by definition. Okay. So what is the formula? Delta H is equal to delta Q by T. Sorry, delta S is equal to delta Q by T. Okay. So the delta S is already given. So just we have to put the formula, and it is delta Q which we have to find. So here this is enthalpy of vaporization. Since this is given in degrees Celsius, we will convert into Kelvin, right? Everybody, are you getting?
Yes, sir.
Yes,
Ah,
sir.
So, 351.5. Okay. Then finally, simply we will do a simple calculation, and we will get the enthalpy of vaporization, right? Got my point?
Yes, sir.
So for the unit purpose, see, this is given in joule per joule per joule per Kelvin per mole. So this is in Kelvin. This Kelvin will be cancelling out, and answer will be in joules, right? Joules per mole, right? Everyone.
Yes.
Huh.
Yes.
So do this mathematical calculation by yourself. This is not a big deal for you, I hope. And everybody knows that enthalpy unit is in joules. So since it is asking a standard thing like enthalpy of vaporization, so we will tell in per moles. So everybody understood this? Hello.
Yes, sir.
Yes, sir.
There are more questions that if you mix two gases, what will happen? If you will mix two gases, randomness will increase. Like for example, this is a popular example. Like this is a thing. Air, two gases are present, two different types of gases. Okay, it can be similar also, and there is a cork here, and we will remove the cork. Okay, so what will happen? This will move this side, and this will move this side. So each molecule will have bigger volume to play around. So this will increase entropy, right? Got my point?
Yes, sir.
So I would request you all to solve the questions. Okay. See, there is another question from last class, that enthalpy and entropy. Let me show you the question. Like, there is no enjoyment and discussion if you are not solve the problem. Means it would be like very dumb. Just you will see the solution and just copy it down without trying it by yourself. So enthalpy is given, means delta H is given, entropy is also given, delta S. Okay. So in this question, this is given. And we have to predict the feasibility. Is it feasible or not at this temperature, right? Please kindly read this question. Done reading the question? Done, everybody?
Yes.
Now try to solve this question, and I will give you a hint that this is talking about predict the feasibility of reaction. Let me tell you, in any question, there is H and S given and talks about feasibility. It is the feasibility comes in your mind. Delta G should also relate with, you should relate with it like with delta G. As if delta G is negative, it is feasible. If delta G is positive, not feasible, not a spontaneous reaction. And if delta G is equal to 0, the equation or the process is at equilibrium. This equilibrium is coming in very much into in your in this topic, but still we will go to the equilibrium chapter and then we will discuss later on. Now just solve the question. Use this formula. Delta G is equal to delta H minus T delta S. And let me know what the answer you are getting. Which example I haven't understood? Which example? This one or earlier one?
This one, sir, about the question.
Huh?
About the question, sir.
Sorry, your voice is breaking. You can message. The one above questions. Okay. This mixing of molecules or this numerical? Mixing of molecules. Okay. See. This. People who have understood this problem, kindly proceed with the solving with the this question which I have given, this numerical. Don't waste your time. So there are two containers which are connected, and earlier it has been blocked. Okay, we have turned off this, and before mixing, molecules are present, gaseous molecules are present in respective containers. Okay, so what we will do, we will remove this cork. Okay, we have removed this cork. So obviously no one can stop the molecules from coming from this container to this container, and these molecules from this container to this container, right? Okay.
Yes, sir.
So what will happen? These molecules, if assuming it like we have 6 molecules here, so now these molecules will go and shift here, some molecules, and some of these molecules will shift here. So each molecules will have greater volume to move around here and there. Okay, they are not limited. They have increased their option of getting, means they have more random energy. They can move around more. That is why we can say that randomness has increased. Okay. Also, the probability of collision also increased because there are other gaseous molecules also. Okay, got it. Thank you. So kindly do this question. Is my pace of speaking is fast for you people? You can either speak or you can answer me in chat, no problem. Means I will, do this according to you only. Okay. Okay. Anybody got the answer? Just you have to put the data in your, in this formula. Nothing you have to do except putting this data in the formula. हाँ जी, ओके। यू नो, हाँ, ठीक है। So let's solve this question out. No, you have to tell that is it feasible or not? Yes or no. The the answer I want is in yes or no. Yes, the process is feasible, or either no, the process is not feasible. Hello, I have jot.
Yes.
I means I'm just getting limited response. Uh, Jesseline, where you are having trouble?
Sir, I'm still calculating.
Okay. You can use your calculator. Means this is not encourageable, but because in the sessions are limited, and you have to do a lot of questions here. So during the class, use it. And in this question, you don't have to means use the calculator also, because you have to answer in yes and no, and after solving obviously. But you can do approximation here also. Ali, where are you? Ali, Ali Muhammad. I mean, Krishna. Oh, I have just, I thought you are writing, sir, I am in Calcutta. You've written, I am in calculation part. Okay, time is up. Let's do this. So we are putting the, value of it. So the delta H is given as 40.63 kilojoule per mole. See, the examiner will, try to confuse you. It is given in kilojoule per mole. So we will, calculate this in kilo. So kilo is 10 power 23. So this has been converted into joule per mole, and the temperature is given 27. So 27 will not work. Why? Because this is in degree centigrade. So we will directly convert into 300 Kelvin, right? After adding 273. So it will become 300. Okay. And we will multiply it by delta S, change in entropy. The change in entropy is given as 108.8, right? Everybody. Hello.
Yes, sir.
Jovita. Jovita, am I pronouncing your name correct? Jovita. Jesselyn, understood? Sabiha, Shaima, Zainab, clear?
Yes, sir. Yes, sir.
So this is like only calculation part. The mathematics you have done. Means we have to do multiplication and all. Means the this formula putting part, the data part is done, nearly done. But what the issue is here is that you have to know this thing. Only after this we can, completely give the answer. So we will, wait. For your easiness, not, we will multiply it by 1000. Okay. 40630 minus 300 into this. So let's assume it like it as 110. Okay. if there would be not much huge difference, then we can do this operation. So it will be 330, right? So it will be coming 330. This much, right? We are doing some approximation, don't worry. Acha, it will become little lesser than this, right? Since we have increased this value, so answer should be lesser than this, right? Everyone, you have to apply this much logic that the answer, this approximation which I have done, is coming, it's taken as little less, little bigger when 110. So the answer is coming is little bigger than expected, right?
Yes, sir.
Since we have assumed it as little bigger, so answer will be little bigger only, right? Is everybody getting this or not? So leave it if it is having issue with you, no problem. The real answer will be, I have used this calculator, 32640. So this 40630 is greater than 32640. So obviously delta G is greater than 0, right? So the reaction will be spontaneous or not spontaneous? Shaima, what do you think?
Yes, sir.
The reaction will be spontaneous or non-spontaneous?
Non-spontaneous.
Yes, delta G is greater than 0, so it will be non-spontaneous. Everybody understood this? Ali?
Yes, sir.
See, if you want to, be clever na, this thing which you have to do in exams, like you will increase its value, little value. So when you will see, okay, we have increased the value, हमने value बढ़ा दी, but still this is positive. So obviously it will be positive, hence it will be non-spontaneous. Got the answer? Everyone? So, Zainab, you understood the problem?
Yes, sir.
Shama, you got the right answer, right way you have solved the question. You have given the answer, which was correct. I'm just asking you, is it, you have done this, you have done this question like this only?
Yes, sir.
Okay, good. So there are, several other questions also. You have to try it. First, try it by yourself. Then it will be, good for you also and for me also to, teach you. Otherwise, I will keep repeating and just telling you, and you're not understanding anything. That will not work in long term. Means one night study does not work with class 11th and 12th. Okay, there are a lot of syllabus and there are a lot of complex things. I know this is a burden to you, means it is burden to everybody because a lot of change in your syllabus and all. But everybody do this, na? People have to do this. As you get, older and older, the life become complex. But still, we have to deal with it, with the situation, with everything which is coming, in front of us. We cannot escape the reality. So we should be able to deal with the reality. So everybody copied this. Please copy it down. This and this, both. There are a lot of questions, like 5-6 questions related to this one only. That will it be feasible or not? Will it be spontaneous or not? Or at what temperature it will be spontaneous? These things. Let me know when you are copying, when you have copied this solution. Is my screen sharing is paused? Can you see my screen? Hello,
Yes,
is it visible?
yes, sir.
I cannot understand, is it visible or not? Yes or no? Voice is breaking frequently. You can message also. No problem. Done with the copying?
Done, sir.
Ali?
Done.
Okay. So let's move on to the next topic. It's a very small topic, but you should have the idea of it. Standard gives free energy and standard gives. Okay, standard gives free energy change. Actually, what happens now? Like delta G is equal to delta H minus T delta S, right? Everybody? I'm not getting any voice from you.
Yes, sir.
So, like if anybody doing some experiment on, for example, some is doing experiment in India, some is doing some experiment in Gulf, some is doing experiment in Europe, and some is doing experiment in in America. So what will some will say that this reaction is going on, it is a spontaneous. Some will say no, it is not going on, it is not spontaneous. Why? Because it is dependent on temperature, right? We have already you can see in this equation also, and we have discussed that at a particular temperature a reaction can be spontaneous, and with a change in temperature it can be non-spontaneous, right? We have discussed this, right? Like we have given example of conversion of water into ice. So at -1 degree Celsius it is spontaneous, and at 1 degree Celsius it is not spontaneous, right? Everyone, at -1 degree Celsius water can is spontaneously converting into ice, but at 1 degree Celsius it is not possible, right? I will stop here if I'm not getting any response from you, because these things I have repeated it multiple times. Sabiha, Sabiha, So kindly right now, when I will call you out, you means people out like Ali. When I will say Ali, Ali, then he will respond in the message. He's responded. Means what is the issue? Or there are several options also that you can, thumbs up or raise hand. Okay, okay. Oh, I'm sorry, Sabia. No problem. Okay. So you please be responsive and ask Dot if you are having any problem. Otherwise, I will, I can just go on and complete the syllabus. What is there for me? It is upon you only to, raise issue or, raise doubts or respond with the answer. So this is temperature dependent. So one guy in the, uh, in Canada where there is very low temperature in winters. So he is saying that water is readily converting into ice. It is a spontaneous. But for example, in South India, there is there is temperature always greater than zero in winter also. So water is not converting into ice. So to standardize things, what we have done, we have taken temperature as 298 Kelvin. Okay, we will when we will talk about delta G, standard delta G, we will take temperature as 298 Kelvin. Okay, and pressure as 1 atm. And pressure as 1 atm. Okay, so at this point, we will say that if this is at this condition, we will say that this is a standard Gibbs energy. This is standard enthalpy, and this is standard entropy. Okay, only there is a minute difference. So this is the case here, which you have to understand that what is the thing that at a particular temperature and at a particular pressure, we are getting delta G, delta H, and delta S. This is for you. If you will do this experiment in anywhere in any part of the world, the result will be same. Okay, got my point?
Yes, sir.
So as we already know that, for example, delta H of reaction is, you have done in earlier classes, delta H of, uh, delta H of react product minus delta H of reactant. You have done this in several times in enthalpy's topic. Likewise, this is here also that delta G of reaction will be delta G of product minus delta G of reactants. So this will be standard. Okay, let's see with an example so that we are able to understand it very with a good understanding. So let's see. Let's take an example of I2 is I2 solid. Acha, in let me tell you why I2 solid is taken, because in this nature I2 is formed in solid state, and in which state bromine is formed? Bromine natural state is liquid, and rest these two halogens, chlorine and fluorine, are found in gaseous state. Okay. So what is happening? I2 is getting reacted with H2S, which is in gaseous form. And what will happen actually after this reaction? HIN solid, this sulfur will form. Sulfur will be in a solid state, and this is in gaseous state. Okay, got my got this thing? So see, what will happen in this question is given of delta G of formation of H2S is given. Okay, delta G of formation of this HI is given. Okay, if anybody wants to make HI in anywhere in any part of the world, delta G of formation of HI is, let me give you the data, then we will solve the numerical. 1.8 kilojoule per mole, and this will be 30 kilojoule per mole. Okay, so delta G of formation of H2S and delta G of formation of HI is given. Okay, so what we have to find, this is the question, find the delta G of reaction, delta G naught of reaction. You have to find delta G of reaction. Okay, so you don't have to try it by yourself. Let me tell you how to do this. So the question, try to understand the question. In this, iodine in solid state is reacting with H2S gas and giving the product HI, which is in gaseous state and solid. Okay, and here only two options, two things are given: delta G formation of HI and H2S. Okay, but delta G of, can you see delta G of formation of iodine and this sulfur is not given, right? So kindly make a note. Delta G of formation of elements, delta G of formation of elements in their standard state will be 0. Okay, be patient. We are going to solve this question. So what I was saying, that delta G formation of elements in their standard state will be 0. Like this oxygen, oxygen is present in this atmosphere in this form only, O2 gas, right?
Yes, sir.
So its delta G of formation will be 0. It will not be mentioned in in your question. We have to take this of delta G of formation of this oxygen as 0. Tell me, if carbon solid is present, this is the natural state of carbon, right? In solid form, its delta G of formation is considered as 0. Okay, are you getting? Like for example, if we have N2 gas, its delta G of formation is also 0. Why? Because this is found out in this atmosphere in this form only. Okay, are you getting this? Can anybody tell this delta G formation of this bromine gas? what will be its just you can message also, no problem. Delta G of formation of bromine. See, the problem with bromine is that bromine is formed in liquid state. That is why delta G of formation of bromine liquid will be 0. Okay. Similarly, iodine is formed in solid state in nature. So delta G of formation of this iodine will be equal to 0. Are you getting this? If there is copper solid, the delta G of formation will be 0. Because copper is formed in solid state, right? Are you getting this? Thus the delta G of formation of element in their standard state will be always will be 0. Okay. Zainab, are you getting this?
Yes, sir.
Okay. Ali?
Yes.
So in this question, say why this is not given, because delta G of this is 0. Okay. Delta G of formation of this is 0. And this is also 0. So but just we will apply it this formula and we will get the answer. Let's solve this question. So delta G of this reaction will be delta G of product minus delta G of product minus delta G of reactant. So what will happen? This reaction. Delta G of product is, we have 2HI, right? So 2 times of HI. HI is delta formation of delta G of or HI is given 30 kilojoule per mole. Okay. So kilojoule we are leaving it as kilo thing is we will leave it, and minus times delta G of and the other thing is 0. So we are not going to count it. Let's write it down for writing sake only. Minus delta G of reactant. The formation of iodine is 0 plus reactant is H2S. H2S 1.8. 1.8. And just we will solve this. 60 minus 1.8. So we will get 58.2. 58.2, yes. 58.2 kilojoule per mole. So that is it. Okay. So delta G of delta G of this reaction, we have got this answer. Jovita, have you understood this question?
Yes, sir.
Kindly note this down. Let me know when you are done. And I can also repeat the steps if you want. You can ask, no problem. You can message also. The group is in focus mode. Only I can, see your chat. So no problem. You can ask without any, hesitation. Done. Okay. Some people are active in chat, and some people are neither active in chat or nor responding. So oh, sorry. So let's go to the next chapter, which is chemical equilibrium. Okay. So in this chemical equilibrium chapter, we will this is a very important chapter because it is no in this electrochemistry. When we will reach electrochemistry in class 12, so we will use this concept very much, this chemical equilibrium thing. So this is also important chapter of the physical chemistry. Okay, so let's start. Wait a minute. Sir, can you take that? When is your this exam, Jovita? October. No, means later October, mid October, early October. Okay, 25th of October. Okay, I think we can reach it there. Means after equilibrium, na, we will start it. Okay, or I will ask you to. Acha, which chapters are coming? If you have any idea. If you have any idea.
Some basic principle and techniques.
Basic principles means this is the first chapter, right? For
Yes.
you people. Okay.
Organic.
Okay. Can you say again? Write this in your chat box. Okay. So I will, take note of it, and I will discuss it with management. Okay. And then we can, do what will be, we will see what is possible. So, some questions. So I have took the screenshot. I will discuss it with management. Okay. So don't worry. So let's start the chapter. Okay. This will take, I think, 5 class. I think. Do your homework. Then we can be very confident about this chapters chemistry. Like you people, anybody got biology in your subject? Anyone? Okay. 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 Sure. Most people are bio. Anyone maths from maths? No one from maths.
Sir, I'm from maths.
Okay. So we have math people also. So like in bio, you have to understand the concepts and mug up the things also, right? And like this like this maths you cannot mug up things, right? You have to practice and get the understanding. Physics also is like this. You have to understand the concepts and you have to solve these many questions and all. This physical chemistry is like physics only. You have to understand the concept, the basic concept of it, and then apply it in numericals. So this needs practice, this physical chemistry. And there are other ways also to deal with inorganic and organic. We will deal it later when we will start. So try to solve the questions. If you will solve the question, you will remember the concepts. Okay. So I will recommend you to solve the questions. Read the question, try the question, and since you have less time, I know, and you have other works also, but still you give time to question for 2 to 3 minutes, at least 2 to 3 minutes. You can leave the question in between. I have no problem. But when you will read the question and try to recall what I have taught or read up the notes, then it will be enough for you. It is not necessary that you are getting the right answer. It is necessary that you are trying. That this trying will also help you a lot. And do not ever try to do a question, give a question more than 10 minutes. It will be better that you try to do 5 questions, or try some very hard question and giving you 10 minutes of it. Either you are having some conceptual problem, or either the question is too tough for you. Okay. So this concept is related with every subject, in physics also, maths also. Bio, I don't know. I have no idea about bio. I have done engineering from Jamia Millia Islamia. So I have not opted for bio. I have maths only, physics, chemistry, and maths. And so chemical equilibrium. So in chemical equilibrium, first you have to see first you have to understand what is equilibrium. Okay, and obviously we are studying chemistry, so we will deal with chemistry thing. So there is some static equilibrium. Static means ruka hua, means not moving. Exactly. So for example, you have done some simple problems of block problems from physics, right? Where, for example, we are applying pressure, no, force from both sides, equal force. Then will it move or not move? it will be at rest. Why? Because the force applied on this block will be equal and opposite. Okay, so it will not move. Good, got it. So it is at rest. So this is a static equilibrium. This is not moving at all. This is at rest, and this is one of the static equilibrium case, right? Okay. So now let's see this example in which a bucket is there. Okay, a bucket is there, and it is filled with water. Okay, it is filled with water, and what is happening? We are dropping more water. Okay, one by one into it. Okay, at a constant speed. Okay, and we have this. We have made a hole here. Okay, and what is happening with the small hole? One by one, droplets of water is coming out of it. Okay, droplets of water is coming out of it. The rate of this both this droplets incoming and going outside is equal. Okay, in this case we are assuming it. So water level, so this water level will not change. Water level will not change, right? Because the volume which is coming inside the this bucket and going outside is equal, right? कोई तो बोलो.
Yes, sir.
So it is not changing. But are we, are you understanding this? That this, we can see that water level is not changing. Still the water is coming and going, right? So what is happening? This is one of the example of dynamic equilibrium. Dynamic equilibrium. Okay. That the state in which it is in equilibrium. However, this is in dynamic condition. Okay. So what is happening is actually that the forward process is equal to backward process. What is forward process? Here forward process is addition of water. Here forward process is addition of water, and backward process is removal of water. Okay, so these both processes are same, equal. So that is why this is in dynamic equilibrium, right? Everybody understood this?
Yes, sir.
Okay. Okay. So kindly write this down. Done?
No, sir.
अच्छा.
None.
Next. ठीक, तो अब देखिए दो तरह के रिएक्शन होते हैं, रिवर्सिबल रिएक्शन और इरिवर्सिबल रिएक्शन, राइट? सो इरिवर्सिबल रिएक्शन, अब इरिवर्सिबल रिएक्शन में क्या होता है, आप सबको पता है, मींस like the reaction will go in a single direction and it will never come back, right? In the reversible reaction, right? So the reaction will go and reactant will go and form a product, okay? And in this reactant concentration will all or concentration, or the reactants overall will always decrease and product will always increase, right? With time. So let's see with some examples. Like for example, the reaction between acid plus base. Okay, it will give salt plus water, right? I hope you all know this. So if they are a strong acid, okay, we have to understand this. If they are a strong acid and a strong base, this will result in salt and water. For example, this acid HCl plus NaOH. So what will happen? This will readily convert into NaCl plus H2O. Okay. So this will never go back in backward direction. Okay, and every bit of HCl and NaOH will get react with each other. The second type is precipitation reaction. Precipitation. Here precipitation is formed. Precipitate is formed. Everybody understand precipitate? You have labs in your school?
Yes.
I hope you have labs in your school, right? So you may have tried out this precipitate thing in your labs. Wait a minute. So precipitation reaction. So what happens in this? For example, we are reacting. This is a very popular example. AgNO3, Ag silver nitride is reacting with NaCl. What will happen? AgCl will form plus NaNO3 will form. Okay. So AgCl is a will form precipitate. Okay. This is silver color, yellow color precipitate. The color is not important here. That is why I'm not mentioning. So immediately if you mix silver nitrate solution in NaCl, immediately it will form AgCl. Okay. Just at the blink of your eye. So it is not going to, convert into this AgNO3 or NaCl. So that is why this is the irreversible reaction. Okay. Other popular example, combustion reaction, which you can see, which you already have seen in your life, daily life. So combustion reaction. For example, if you burn up your paper is one of the organic matter. It has carbon in it. Okay, so if you burn your paper will not, the burnt paper will not ever convert into this, the once again the carbon. So it is not possible. For example, coal is burnt. Coal is made up of carbon. When we react carbon with oxygen, it will convert into CO2. This reverse will never happen. Okay, this will go in forward direction only, and both will get exhausted, and this will form. Okay, have everybody understood till this point?
Yes.
Okay, good. Kindly note this down. Done. Second one again. Second one. Which one is second? Precipitate reaction. Okay. See what will happen. Let's give you this. Generally, we do precipitate reaction in a test tube. Okay. So this is a test tube. What we are doing, this is the NaCl solution. Okay. Let's assume this is the NaCl solution. NaCl solution. Okay. Water plus H2O. Water is always present. Water is a medium as a solvent. It is acting as a solvent. So what we are doing, we are taking a beaker and we are pouring this AgNO3 in it. Okay, AgNO3 in it. So what will happen? The instant which if we have dropped like 5 drops of it, so at that instant only we will see, after that instance we will see yellow precipitate. Okay, we will see yellow precipitate here, this yellow thing. Okay, so this will be AgCl. So we will get yellow precipitate of AgCl, and this is precipitate. What is the characteristic of precipitate? That they do not dissolve. They don't dissolve. Okay, so they are not dissolving. They are not reacting. Okay, so this is why we can say that this reaction is a irreversible reaction. They do not dissolve or do not नहीं लिखा है, ठीक है, समझ जाओ. They do not dissolve. Okay, precipitate do not dissolve. That is why they get like sand do not dissolve in the water. They get sedimented in the bottoms of the container, and that is how AgCl also get comes at the bottom of the this. Okay, understood? Who was asking? Zainab. Okay, good. Acha, done copying, everyone?
Yes.
Okay, so let's move on to this reversible reaction. There are two types of reaction: irreversible reaction and reversible reaction. So our main concern will be reversible reaction. Reversible reaction, and we will go into detail of it. A reversible reaction. Okay. So in reversible reaction, let's take an example that A plus B is reacting. Okay, and what is happening? We will be using this kind of arrow. Okay, we will be using this kind of arrow, half arrow, both sides. Okay, and forming C plus D. Okay, so A plus B are reacting and forming C plus D. Okay, this is a forward reaction. This is a backward reaction. Backward reaction. Okay, so what is happening? These are reactants, right? A plus B are reactants, and we have taken, for example, we have taken 1 mole of A and 1 mole of B. So by time, what is happening? That A and B are getting reacted, right? Like we will go to step by step. Initially क्या होगा देखिए. Initially A plus B are reacting and forming C plus D. Okay, C plus D, obviously they will form C plus D. So this is a forward reaction. Okay, after some time, what will happen? After some time, what will happen? The trick is here. Not the trick, means the main thing is coming that C plus D has formed in large amount. Okay, and what will happen? The C and D molecules which has formed are start reacting with each other, or have started reacting with each other, and thus C plus D are getting reacted and forming A plus B again. Are you getting this? That A plus B has formed so much large amount of C and D that some C and D are getting reacting, and the reaction will get in opposite direction, and they will start forming again A and B. Okay, understood? So this is a backward reaction. That is why we have made this forward and backward are happening simultaneously. Okay. So what is happening in real life? Means this theoretical thing that A plus B are constantly A and B molecules are constantly colliding and reacting with each other and making C and D. And C and D are colliding with each other and they are making again A and B. Are you getting this? So A plus B is also reacting, C plus D is also reacting. So both the phenomena is getting on simultaneously, right? Are you getting this? So what we'll say, we will say that, so since both are going on constantly, so we will say the rate of forward direction, rate of forward direction is equal to rate of forward reaction. Rate of forward reaction is equal to rate of backward reaction. So both are happening simultaneously. Got my point? So there are several examples of it, real life examples. Like for example, let's see that N2 plus 3H2. This will be in equilibrium with ammonia. Okay, this is a common example. This PCl5, breaks and form PCl3 and Cl2. So in this also, this PCl5 is constantly breaking and PCl3 and Cl2 are constantly reacting and again making PCl5. So these things are happening simultaneously. Same is happening with this one of the example, N2 plus O2. Okay, H2 plus I2. They are reacting and forming 2HI. Then we have many examples. So got this? So for example, in this case, let's see, we can say that rate of formation of NH3 is equal to rate of decomposition of NH3 is equal. See, in NH3, this equation, this formation of NH3 is taking place by reaction of these both molecules. So rate of formation of this NH3 is equal to rate of decomposition of NH3. Are you getting this? Everyone got this? So finally, we can conclude, this is a final conclusion, that concentration of NH3 is constant. Why? Because decomposition and formation of NH3 is not changing, because both are equal. Formation and decomposition of NH3 is equal. That is why the concentration of NH3 with respect to time is constant. Have everybody understood this? Kindly respond.
Yes, sir.
Yes, sir.
ठीक है. So let's conclude the class today. I would request you all to solve the questions, the homeworks, and we will discuss them. If you will have problem, you can please do this and revise this also, and note this down, because without noting the things, we will start from here only. You should have the understanding of this. Kindly revise this much at least. It will take only 5 minutes. Kindly revise this only, this page, the last part. This is very important, so don't forget to write this down.